Alright, so one of the first things I did was I considered um, on the robots, like let's say for example, this humerus bone. Um, what kind of orientation should my DC motors have? And the first idea I had was sideways with the little pulley on that side, and then the strings would be coming this way off of it. So I would have them each mounted like this, side by side, and then the strings coming this way. Now, I realized the problem with that design would be airflow. If if I'm putting my vents up here to let out hot air, and my cool air intake is coming this way, it's coming up, then I can't have all the motors oriented in a perpendicular fashion. So the problem with this design is as the air is coming through this way, it would bounce off here and go around the first motor um, because of aerodynamics. And that would leave hot spots in between motors right here, which would get really hot. So in order to address that, I need to orient the motors in a way that they can be cooled to maximum efficiency and stacked, because I need to be able to, like if I did it that way, so it would be like motor, 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 and they'd be stacked like that. Uh, they'd be stacked like that, and no air would be able to get to any of them except the outer ones. The air would be coming from this way and it would just part and they would just get really hot, all pressed up on each other. So it wouldn't work. So that's what made me realize I need the motors to be like um, oriented in a way that makes sure that the air can access them, because the air, like I said, is going to be coming from the distal end of the humerus to the proximal end of the humerus, with the vent lines on the top and the air intake coming from the bottom. So I thought about putting the motors vertical off the bone. So let's say this was the bone from the side view. Then putting the motors like this, and the pulleys going this way. But the problem with that, even though it'd leave nice air channels, is it would get pretty tall and you couldn't really stack them. So like the next motor would be here if I stacked it on top, and so I couldn't even really put too high because the motors would actually like stick out above the arm's profile. And so I would only be able to put one layer and I wouldn't be able to stack them. Um, so that kind of ruled out the vertical orientation of the motors. So then my next idea was to, and this was the one that I was really happy with. My next idea was to put them laying parallel to the bone. All right, in rows. So it'd be like motor, and then pulley, pulley, motor, and then we could put them next to each other like that. And so on. Just all the way on down the line, just like that. Like that. And what's great about that is the air can flow right through, upward, through the middle of each column of motors, cooling them off. And also, another advantage is when you can stack them. So like I'll draw a little bit of a close-up of this. So like here's the motor, here's the pulley, and then you can stack it like this with another motor. Obviously another pulley, and then you can do another motor. I think I could possibly stack them 3 high, so that they can be just mounted right on top of each other, and then they're also going to be like that. So this is like a side view looking down from the top at an angle, and yeah, so it's just this being mounted higher and higher in the z-axis. So this is the y-axis, and then the x-axis, and then you're stacking them in the z-axis. So you can make it as tall as you want, and the air can just flow between the columns of motors and cool them all off. And I also decided, this is the next aspect, each motor is going to be wrapped tight in cotton cloth. That's how they're going to be mounted. They're going to be wrapped tight in cotton cloth, sewn tight, and taped on. Now the cotton cloth wrapping each motor will enable me to spray all the motors with my mini sprinkler system, soaking the cotton cloth that wraps each motor. And because of the thin membrane of tape that's going to be surrounding each motor, the water won't actually contact the metal of the motor, so that should prevent corrosion. And the cotton cloth will hold the moisture quite well, and it will also spread the moisture underneath the motors and around the motors uniformly, so that as the air blows through the motor channels, it will draw a lot of evaporative cooling and heat off of the motors. Okay, so I'm going to be just strapping each motor, mounting it on top of the next. Also, let me take the questions from Save the Man. What are you currently trying to accomplish? Can you not use the full surface area of the bone to mount to? Yeah, I will be. I'm just telling you the configuration the motors will be in. What's up, Hoffman? Or do they need to be mounted on the same side? You need to be able to fit motors all the way around the bone, bottom and top, and both sides. You're going to be packing motors everywhere that there would normally be muscle mass. That's the space you have to work with to fit motors. The name of the game is to fit the most motors you possibly can. The more motors you fit in the robot's body, the more strength the robot will have. It's that simple. But you need to fit them in such a way that air can flow in organized channels in order to allow the motors to cool. It's very important that the motors don't overheat. So soaking each motor with cotton cloth that wraps each and every motor, that is separated from the metal of the motor by a thin membrane of double stick tape in order to prevent corrosion. That cotton cloth will absorb water that will be sprayed onto it, and it will draw away heat. Costly amount of motors, that's irrelevant. Cost is not relevant at all. Okay. Yeah, the whole robot might have 600 motors. Let's say on average they're $20 each. $12,000 worth of motors. Small price to pay. And you're able to add them incrementally over years of time. And it won't be a problem at all. I've already got like 40 motors, so that's enough to handle the majority of the actuation of the fingers and some basic actuation of the arms. So, I mean, you can even get them for like $10 each. I just hold these motors out of servos, hobby level servos. Alright, but I might upgrade them someday. Obviously, that's always an option.